sense a change in our enemy's behavior.
I used to like dogs. Oh, right now I trade at a garden.
Hello everyone, this tutorial will show you how to create and use vision sets and overlays in Black Ops 3 Mod Tools. Vision sets apply a bit of colour filtering to the game, similar to LUTs. These, however, can be activated and deactivated via script and can be applied per player. Create a file for the vision set you'll be using, or just copy an existing one. I've provided a link in the description for all of the vision files that I have. These always have a .vision extension. I recommend naming it something simple and relevant, as you'll be referring to it many times in the script. Create a folder called Vision in your Maps folder if you don't already have one. Then place your vision file in there. Alright, let's start by going over the basics of the vision file. Now generally the first value you'll see, unless yours has a section for Revive FX settings, is VKTT, which is the colour temperature. Its default value is 6500, which is white. Next is VKTS, which is the saturation level, ranging from -1 to 1, with 0 as the default. After that we have VKTC, and that applies a colour tint. So there are 4 values here which represent the colour channels, red, green, blue, which can be between 0 and 1. And then the last value is intensity, which is measured in stops. I recommend not going too high or low with that one. We also have VKTO, which applies a colour offset. These are also RGB floats. The rest of the values in this file create a colour ramp, and each of these lines define either the colour, anchor location, or midpoint location for each point on the ramp. The last value sets the blend amount for the ramp. If set to 0, none of the ramp is applied. And of course, when set to 1, 100% of it is applied. Okay, now we'll take a look at overlays, which are much more interesting. They can distort or warp the player's view, refract light, and they can be animated in a variety of ways, like with a sprite sheet, or with UV scrolling, rotating, or zooming. You don't have to use one along with your vision set, but they are often the key component of creating all of the interesting effects in the examples I just showed, unless of course you're just going for something simple, like before turning on power in Ascension. I'll start by showing you how to set up a basic static overlay image in Ape, then we'll do a proper animated one with some warping and refraction as well. Pop into Ape and create a new material. I'd suggest first making a new GDT for all of your overlays and creating it in there. Set the material category to 2D and the type to Refract Reveal Blend. Now you'll need a semi-transparent image to overlay on the screen when it's activated. Create a new image in Ape for the color map and drag over the overlay image you made to set the image usage to 2D and make sure that both MipMap Disable and Streamable are checked. Now add in a normal map if you want. This is what the game engine will use to refract light. Make sure this has the same settings as the color map. If you select normal map instead of 2D, you'll probably get an error. Adjust the refraction settings and any other settings you want to change. Then hit New Asset to create the PostFX bundle that we'll be referring to in the script. Name it something like PSTFX, then whatever your vision set name is. Then change the asset type to PostFX bundle. Enter in your filter overlay material name, then match my settings for a static overlay. The number of shader constants should be 1, the animation should be hold, and the number of channels should be 2. Now for scripting. For this example, we'll make a separate script for applying the vision set, but note that it can be done in any other script you already have. Create a GSC file named after your vision set in the scripts ZM folder of your map. Add in 2 of the shared scripts, Vision Set Manager shared and System shared, at the top with the other usings. Then define a namespace that you'll use to identify this script in other scripts, like your map name GSC. Write an auto-execute function, then register your vision set and run the function to initialize it using the register function from the system shared script. My function is called init, so that's what I'm writing in here. And yes, that and sign is mandatory. In the init function, register your vision set by using this function from the vision set manager script. First parameter is vision set in quotes, then your vision set name. The remaining parameters are not as important as far as I know unless you're using a lerp function, except for this should activate per player 1. That should be 1, which is true. Write the same register info function for your overlay, making sure to replace vision set with overlay, and also you'll be giving a name to your postfx bundle, which we'll use to reference it in the rest of the script. Next, find where you want to activate your vision set, and write out this activate function from the vision set manager script. This should probably be put in a function that is called on a player so we can use self, otherwise be sure to define the players affected somewhere in this function. The activate function's essential parameters are type, name, and player. Copy these two function calls and paste them wherever you manage how and when the vision set and overlay are deactivated. Change the word activate to deactivate, and now you are finished with the GSC. Create a CSC script with the same name as your GSC, then add in the same usings and namespace as we just did in the other script. Write another system register function that runs your init function. This is the same as before as well. Now, we'll register the client-side information. The first function is slightly different than we used in the GSC. This one is register vision set info. Then the parameters are name, version, step count for linear interpolation, vision set from and vision set to. If you're not going from a different vision set into this one, then set the vision set from value to undefined. Write a second function to register the postfx bundle. This one is register overlay info style postfx bundle. Name, version, step count, bundle, and duration, which can be left out if you deactivate it in script. The bundle parameter should be the same as what you named your postfx bundle in ape, in my case PSTFX cursed, and then the name should be the one you gave this bundle in the GSC script when we registered the overlay info, which for me was ZM cursed postfx. The last thing we need to do is add this to our map zone file, as well as our map name GSC and CSC. In your zone file, add the path and file names of two scripts we just created, being sure to first write script parse tree. Then we'll add in the vision file as well, which is preceded by raw file. Finally, write script bundle, comma, then the name of your postfx bundle. Pop over to your map name GSC and add using scripts ZM, then the name you gave your files. Then copy that line and paste it into the usings of your map name CSC. Okay, that's it. You should be able to build and run your map. This is the result of the static overlay and vision set I made for this ZM cursed script I wrote that can be activated via a trigger and then runs out after the duration is reached. You can find a link to this script below in the description. Now let's do an animated, sprite sheet based overlay and see what that can add to the experience. Head back into Ape and create a new material, same as before. This time, the material type we'll use is Warp Aberration Refract Screen. Add a mask in the Aberration section. Make sure it is set to reveal map and that MIP map disable is selected. Adjust the settings for the aberration amount and the channel factors. Then add in a normal map to handle the refraction, just as we did before. Now add another mask. This one will affect where the warping is and isn't on the screen. Adjust the warp amount to your preference. Lastly, add your sprite sheet as the color map. I made this one from the frames of the animation that I created in After Effects. Instead of 2D, this one actually should have the image usage set to diffuse map. In the color map settings, enter the number of rows and columns that make up your sprite sheet. Mine was 30 frames packed into an 8K by 5528 pixel image, which makes 6 rows and 5 columns. For the flipbook time, I put the duration of the animation, which is 2 seconds divided by the number of frames. Create the postfx bundle asset to go along with this overlay material. Follow these settings other than the length and you should get a decent result. I have yet to work out what every value affects, but I've done several hours of testing and this has so far yielded the best result for a flipbook animation overlay. Heading in the game, I've set up some vision sets and overlays I created to demonstrate the sorts of variations that can be made and how to apply them for some cool and interesting results. I hope I've been able to help. Thanks for watching.